Hello, this is Pierre, and by the end of this video you will see how 7702 integrates with classic 4337 icon abstraction. So the idea is to send user operation from this EOA and being able to batch transaction, which means one signature for multiple on-chain actions, which is a breakthrough improvement of the Ethereum UX. This is already possible with smart accounts, but with smart account you have to migrate friends to that account and it's a friction to adoption. So yeah, 7702 is an EIP that enable all EOA to behave like smart contract accounts. And yeah, without talking, let's see it in action. So the first thing that we can do is just to make sure this EOA has no code attached. Okay. By the way, we're operating this demo on Odyssey, which is a testing layer 2 that has all the future EIP. By future, I mean the Pectra EIP, right? So we'll be able to send on 7702 transaction. And to help us doing so, I programmed a little CLI that basically is a wrapper on top of VM functionality, and that will help us get the authorization hash, sign the authorization, activate delegation, means sending the signed 7702 transaction, and this will permanently attach the delegation designator to the EOA. The delegation designator is a fancy word to just the address of the contract that we want to execute when we talk with this EOA, when we call this EOA. All right, let's see it in action. So first, let's get the auth hash. Oh, good. I'm just gonna put here, okay. And then let's sign that hash, okay. And then let's just activate. So by the way, this hashing and signing could have been grouped in just one action. I just wanted to test for like the self-custody flow. If you want to send the hash to someone else, sign it, and then get it over. Yeah, I wanted to test the flow as is. Okay, so we can take this signature and we can activate the delegation. Okay, so from now on we can do cool, super power thing. So the first thing probably is to reproduce the same command that we just done, right? Okay, and right now we can see that the code is no more empty. It has what we call delegation designator, which is exactly this address. Okay, this address is the address of the smart OpenFort smart contract account, and we can call actually function of that account. So if I owner, okay, let me just replace the address. Okay, so we can see that I'm the owner of this account, and let's check, for example, if it has an entry point, because 4337 needs entry point as well. Oh, sorry. It's just things that I need to change. Okay, so as you can see, we're working with the V6 entry point. Oh, good, that is deployed on the Odyssey blockchain. So right now, what we want to do is to try to actually send user operation. So for this, we need to run a local bundler, and I will use Alto to that extent. So yeah, the head of the config shows us that we connect to the Odyssey blockchain. Okay, so yeah, let's run the bundler. So the goal of the bundler is just to bundle user operation and then call handle ops to entry point to send them on the element. Okay, so right now we can actually send try to send the batch transaction from our EOA. All right, okay, and then we have this one. Okay, and we can see it as a transaction hash that we retrieve from the bundle logs. And we can go there to check what happens. Okay, so this is the address of the bundler to a WAN that interact with the entry point contract, going through all the validation flow that we know from the classic account abstraction. Okay, and yeah, one thing I just want to show is how cool it is to program in that environment. So for example, here we use the smart account library to interact with our EOA, because right now it has all the code of an EOA, so you can like take it as is and do whatever you want. Here what's funny is like when you do the get address, you return the EOA address. Okay, and yeah, other fun stuff is that, for example, you can, I don't know, let me know in comments, but I've noted that right now we have two nonce. We have the nonce that is like the transaction count of the classic EOA, and we have the on-chain nonce that is stored on the entry point. It's a bit weird, but works perfectly like a charm. Okay, that's it for me, and yeah.